Good morning and welcome to the channel, everyone. I'm Nelson, and this is the introduction video for a new series that I've started here. It's called Programming for Posterity. And the point of this series is firstly to show the process of making a game, like a first-person shooter game. This is in the style of the 90s. Some people will call them like 2.5D or maybe even less than 2.5D in this case. You'll see in a second what it looks like. Um, and making this game from scratch with a few of my friends, with myself doing the programming. So we're not using, well, I'm not using any commercially licensed off-the-shelf engine or any code from anyone else except for like SDL2 for some basic stuff like input and audio. Uh, and I will show you now, do a transition to what I'm talking about when I say the game. To let's see. Here we go. So now you can see this is sort of what the game engine looks like, right? Um, a loadable, interesting level. Have a look around there. So this one is fairly dark. There aren't any enemies here, but we can fix that. Let's see. Where do we start off? We started off here. We'll put some guys around the place, like a couple of these guys, some of these guys, maybe. Place. And God mode on. Have a look here. Oh, that guy I placed in another spot, so good stuff. These guys are getting badly affected by the light. But we can fix that, right? We've got our level editor here that I created. We can, let's just make, let's see. We'll make this like full bright all around here so you can see this guy's better. Delete that guy. Yeah, so that's what it looks like if it's a difficult, right? Oh, and that's what it looks like if you die. For now. Okay, so that's what we're talking about when we say that's what we say when that's what we mean when we say we're working on like a first person shooter, right? I'm working on a first person shooter. That's the engine, the custom engine. So some parts of it are already built, but over the course of the series, I'm going to go through as many of the components as possible to go through to explain how each one works kind of in principle, why you would build them, why I've done things the way that I've done them. And then we'll also, I'm sure, along the way end up with a bunch of videos where it's me adding new features or fixing bugs and showing that. In fact, spoiler, some of those were already made because I was doing that work anyway before I wrote a proper intro and overview video. And what kind of what's the kind of details of the engine? We can get into a lot of the really nitty gritty details later. But for now, suffice to say, so the level geometry that is the representation of the map is like tile based. So you maybe would have seen that already from like kind of guessed that based on seeing the game in action. It's kind of like Wolfenstein in that regard, but it has a z-axis, right? You can go up and down, and the floors and the ceilings have variable heights, right? And for like game objects, they're rendered as sprites. Then not 3D meshes, but they're sprites, and they're scaled based on how far away they are and stuff like that. And yeah, they're affected by, as you see in the video, they're affected by like lighting. There is sort of color map palette shifting stuff going on. We'll get into the specifics of that in another video. But yeah, basically high level, we're making a game. This series is going to cover the making of the game, and part of that is, you know, programming the engine for the game. And that's all part of it as well. And because I'm the programmer, I guess a lot of the emphasis or the perspective is going to be from the engine perspective, right? There's gameplay programming there, but a lot of the explanation is going to be at the sort of at the engine level, right? Because the engine is being purpose built to support just the gameplay that this game has. So about myself, as I said at the very beginning, I'm Nelson. So I'm going to be your host on this series programming for Posterity. I like I like shooter games, I like 90s shooter games, and I generally like that sort of aesthetic of games from the 90s and the early 2000s as well. But I have a really soft spot for that aesthetic of games from the 90s. I'm not an artist, so I'll spare you my attempts um, to describe it kind of discursively or with words. But I think people watching the video probably know what I mean when I say the kind of 90s games aesthetics. I'm a programmer for my job, not a games programmer for my job at the moment. You can say I work at a big tech company, and on kind of like would you call it enterprise software? I don't know. Like basically, I'm a C++ programmer for my job, right? And in the past, I've worked as a C# programmer as well, or like C# and C++ kind of mixed together. But nowadays, it's pretty much entirely just C++. Um, and I've done that for many years, I guess. So that's a qualification of sorts. I mean, what seems more salient to me is, many years making little bits of games, sort of like bits of technology for games, maybe you would say, my own, not for other people, and not collaborating with other people. Last year was the first year, so that would be 2024, was the first year that I got really serious about getting stuff just done and out and released. And last year I ended up making 3 games. Two of them was complete by myself, were complete by myself. And then the third one was with a friend that I'd made who was an artist. And then that person also is now working on this new game with me. So that's really fun. And you saw a bunch of their art already in the footage of me just playing the game then. And then also on the team at the moment, there are 2 level designers. And I don't know, I have great stuff to say about them, but I guess I won't like dox them in the video. But you'll see. Oh, that actually that space that was very dark, lots of moody lighting going on. That was made by one of those guys, right? Okay. And my goal in the video, in this video series, like I said, was to kind of document the whole process. But part of that is, I got a huge amount of value out of some books that I read about. Do I have them here? I don't know. Showing you a book in the video, but some books by like Fabian Sanglard about Wolfenstein 3D and Doom. So lots of really interesting details about the engines, and of course, first and foremost, John Carmack like open sourcing those 2 games is really cool. I appreciate that so much. I got so much out of reading the code for those games. And so I wanted to document the process of making this game, like a lot of the details of it. And then also when the game is released, to release the source code for the game. Not under like a, probably not under commercial license so that people can just recompile the game and sell it, but, open so that people can read it and learn from it. I would be really flattered if people read it and learned it, or even if they read it and it was just interesting, that would be cool too. But then the videos hopefully will kind of be a helpful companion to that, and also just the explanations in there. There's lots of things, I don't know how exactly to describe them, but there's lots of things that you end up making for games that are not kind of like conceptually really clean bits, or things that there's a name for, or things that are kind of glamorous or that people admire a lot, but they're nonetheless really important. And if you write them a bunch of times, or at least for me, when I write them a bunch of times, I think, oh yeah, this is like a valuable thing. I don't really have a name for it, but And I've never seen somebody describing this. I've only picked it up from either doing it a bunch of times myself or just noticing it in code that I've read, like proper game code from a real game that was released, not like a tutorial or a sample thing. Because those tutorials and samples, I feel like, don't contain this kind of code. This kind of code that I'm struggling to find a name for. But like, I don't really have an affordance exactly for that. But yeah, hopefully by watching the videos, you'll get a sense of what I'm talking about. You'll see some of this stuff for yourself. So this video series is for people who, I guess, either people who are just interested in seeing somebody programming a game engine from scratch and making a game from scratch, or people who want to learn about it, right? I think it's pretty valuable to see it happening in real time and kind of try to follow along, and also to see explanations. It's definitely useful, I think, to see the explanations happening in real time and in context of code, and in the context of someone trying to fix something real, or to add something or whatever, and also to just explain it, which is what a lot of these videos is going to be. Obviously, it's just to explain it in the context of the code and being able to run it and show and step through and everything. So if you are interested in just seeing that, you think it sounds interesting and you want to check it out, then this for you. If you want to learn about it from seeing somebody do and try to follow along, and then when the game is released, see the source code, also definitely for you. And I'll say this, I'll reiterate this again at the end of the video, because I have it written down in my notes to do that. But if you are following along and you have any questions, something sort of piques your interest, or if it doesn't make sense, my explanation doesn't make sense, or the code doesn't make sense, please remember to leave a comment on the video to tell me about that, and I will do my best. And I'm anticipating, as my pessimist, I'm anticipating not that many comments. So the odds of me finding your comment and then addressing your question in a follow-up video, I would say, are rather high. So keep that in mind. Okay, so then to move on from kind of meta level stuff to some high level things. This video is not the entire series, obviously, right? But we'll cover some material in this video that is at a high level, just to sort of dip our toes in, and then there'll be follow-up videos that explain things at a high level before we get into details as well, or alongside it, let's say. But the first thing to talk about is what makes a game work, right? Like, what's a game? Well, and maybe this is a boring question. Like a video game we're talking about, but what makes it work? The way that it operates is pretty much always a loop where you get... do I have a document? No, let's just talk about it. So the way it pretty much always works is it sits in a loop, right? You can imagine like a while loop or a for loop, just goes over and over and over the same thing over again. People tend to think of this as being frame by frame. And I think that this is a good abstraction. It doesn't have to be exactly like that, but it definitely simplifies life a lot if you think about each step through the loop as being one frame, right? And a frame, we're talking about like on the screen, when it renders the image, a complete image, right? This is how a modern game is going to work. You're pretty much going to end up with an entire screen's worth of pixels getting updated once per frame, right? Something like that. So the final thing that it's going to do, let's say the final result of one go through the loop is to produce all these pixels to the screen. Now also there's other stuff that it produces, right? So the output is not only pixels, but it's also audio, right? Likely, and maybe force feedback, other stuff like that. But that's more kind of like on the periphery of what we're talking about, right? The most important thing for everybody is probably pixels. And then the other things that you'll want to do every time you go through the loop is get player input, right? Because the player is interacting with the game. That's an important part of it being a game. It's not a video, and it's not, screensaver. It's an interactive, real-time sort of application, right? And you guys all know what that means. Get input could be gamepad, it could be keyboard and mouse or other stuff. And then in between those two, so let's say on a frame, the first thing we do is we get the player input, right? And the last thing we do is we output like some pixels and audio stuff. And in between that, we're going to do this thing that we might call update, right? And that's a very vague term. What does it mean, update? A big thing, let's say a big concrete thing that it might be doing is physics, right? Because you might have game objects that are in some kind of, that are in motion, right? Or there is some kind of physical force being applied to them. They might be getting accelerated, they might be falling, they might be hitting something else, right? Or they might be passing through some kind of non-solid trigger volume, right? All these kind of things are possible. And maybe not in every kind of game, right? But let's say we're talking about a shooter here, so that's the case, right? There's updates to do with physics that have to happen. And once you start getting into turn-based stuff, obviously this is a little bit different, but let's say in a real-time game, another thing that has to happen in an update is the AI for the enemies, right? You have monsters walking around during the update phase. They need to decide what they're doing. They need to detect if they bumped into something. They need to turn around. They can see the player. They want to shoot at the player, stuff like that. So those are all kind of things that can happen in update. Animation, of course, is another thing, right? So depending on how animation works, maybe that's the same as AI. You know, you'll see how that stuff works in my game engine. You could see in the video that the monsters were moving around, right? Sometimes they were deciding to walk towards the player, sometimes they were shooting the player, and they were animating, right? So that's kind of an example of what we're talking about. That stuff happens in the update, but then of course you see the evidence of it. The pixels get put to the screen in the update. Sorry, in the output thing. So if we say we have the game is a loop, and inside the loop, broadly three things happen: input, update, output, right? That's the point I wanted to make here. And you would have seen that in the footage that when I was just playing through the game then. And as I mentioned before, once the series, well, not once the series is concluded, once the game is released, right? Whether or not the series is finished at that point, when the game releases, I will be cleaning up code and open sourcing all the source code for the game. So that doesn't, obviously that doesn't include like the artwork for the game. I guess there's a possibility that could end up getting open sourced, but I feel like that's not my decision. I feel like people that I work with on the game who generated the art should decide if they want that to be open sourced, and I have a suspicion that they won't. That's not usually something that people who are creating visual art like to, and that's fine. The point is the code, right? You could substitute your own graphics, or you could do whatever, or you could just read it to understand it, right? The point of open sourcing it is not to make it so that in this sort of situation, the point of open sourcing it is not so that you can build it yourself. The point is, or that you will be able to, but the point is that you can read it to understand how things work inside, right? That's the valuable thing, I think. Like, I never built Wolfenstein 3D or Doom from scratch. I wasn't interested in doing that. I was only interested in reading the code to see how stuff worked. So I hope, I hope when that happens, it'll be useful for somebody. And then, the only other thing I wanted to say in this brief intro video before I say bye is, once again, please leave comments. This video, maybe there's not anything that is kind of confusing that is, will leave lingering questions in your mind to ask, but in the future videos, emphasize, please ask questions, treat it like it's, maybe like a class or something where you can ask questions of the teacher on topic and get answers, and I'll do my best to answer as many of those questions as I can. And just look out for future videos, and I'm really looking forward to going all the way through this series, through to finishing the game, along with everyone who wants to watch the videos and ask questions and stuff. Have a good one, guys. Have fun, and I'll see you later. Bye for now. And I forgot to say when I was recording the other part this is, let's say, the structure for the series that I had in mind, right? So we're going to firstly do an overview video. That's not this video. That will be one that where I'm going to show more code. I'm going to show sort of some of the linkages between the different parts of code and give a little bit less of a hand-wavy explanation for why there are different components that do different things, why they need to be the way they are in a game, why I created them the way I did, and all this kind of stuff. Then the rest of this stuff is broken down into sections. There's a drawing level geometry section. We've got drawing walls, drawing viz planes, mids, and animating textures. Yeah, these are probably going to be separate videos, like fairly short videos, but I'll go into a lot of depth in each of them about how these things are implemented and why they're implemented the way they are. It's fairly interesting, I think, and some of it might even be interesting if you want to understand how things are rendered in Wolf 3D and in Doom, because these conceptually are modeled after the way things happen there. So that might be interesting perspective for someone who wants to know about that. Player inputs. Yeah, there might be other stuff in player later on, but for now, for representing the player, most of the interesting stuff is just to do with inputs, I think. And there is a lot of stuff to talk about as far as inputs go, right? So yeah, we'll get into that when it's that video. Maybe that even should be multiple videos, because there are different interesting topics that are somewhat separate about that. Game world state, there's lots of interesting stuff here. It's a bit messy. We have, what I call game actors. They're, things that you would draw a sprite probably for them most of the time. Almost all the time you would draw a sprite for them. They might be animated, they might move around, they might have health, they might die, stuff like that. Doors, that's pretty self-explanatory. And so this is also, like, doors are a kind of level geometry, right? But we're talking about how they behave as game world state and not how they're drawn. Push walls, similar thing to doors, right? It's those secret walls. You push on them and they move in the game. Height movers, this is something we'll explain but it's about the floors and ceiling, the heights of floors and ceilings can be sort of scripted to move in the game to make elevators and stuff like that. We'll see that when we get into that. Adding a z-axis to a 2D Raycaster, that's sort of related to the floors and ceilings, but it's just about how you can move the camera up and down, you can look up and down at stuff. That's the most basic thing. Then, we can actually climb upstairs. There can be enemies. You saw a little bit of this in the footage of me playing the game. Enemies can be lower than you, enemies can be higher than you, stuff like that. So this is kind of like this is a bit of a hack, right? The way that it's implemented in this game is a bit of a hack. It's similar to the hack in, say, Doom. Maybe it's hackier than in Doom, but it's not a competition. Anyway, when we get to that, we'll talk about it. That's kind of a funny one. It's not a conceptually clean thing, but it's probably an interesting thing. Serialization, deserialization. I mean, that's kind of what it says on the tin, right? We've got the map format. We've got how we generate C++ code to encode game data, so like gameplay data about enemy. Well, no, not only gameplay. So just a whole bunch of game data, how that gets encoded as like C++ structs, and mostly like statically allocated arrays of these structs. But in other cases, like we load stuff from disk and all this. But this is all like I've got like Python scripts that generate C++ code to do this stuff, right? So that'll be a big messy video or series of videos maybe explaining that stuff. Why I did it that way, why you might want to do it that way, why you might not want to do it that way. And then save load is like saving and loading the game state. That's really interesting. That's one of my favorite topics. So when we get to that, that'll be a lot of fun. And then also, I mean, I didn't put it in here, but there could also be a video about the way that we serialize, deserialize, like game options and like input bindings and stuff like that. But that's less interesting. We'll see if we get around to that. I might add it to the overview thing here. Drawing sprites. I talked about this before. Actors, these game world actors, they could have sprites. They could be animated. There's sort of like a state machine that controls the animation and the behavior of them. And then we've got traces, which is an interesting thing. That will be, yeah, I hope I do a video about this because I think it's pretty interesting. It sort of ended up being um, a different way of rendering things that move in the engine that's not sprites. It's like a rendering just sort of like geometric shapes, uh, maybe more like you would do in like a 2D rendering library. So we render filled lines and filled quads essentially, right? Basically what that is. But you'll see that that's a thing that I created for like kind of like laser guns. They look kind of like maybe similar effect to the laser guns in Dark Forces. Okay. And then in the UI, there's a ton of stuff here. I don't know if we'll cover all this. Hopefully I can cover all of it. My UI rendering library, I put a thing down at the end here about the kind of library. It's like there's shared code that gets used around the game. I think the API is not something that someone else would want to pick up and use, but we can think of it like being a library. But there's other stuff in here that's just generally useful for games, like rendering a HUD, rendering text, because we're not using something off the shelf that already has this. We do it in a way that's kind of interesting to look at. Console, I think, is an interesting one. I think it's really useful to have in the game. It only ended up taking a day or two to add this, and I think it's been really valuable just as a testing tool. And then, the map editor is a really interesting one. So a lot of the UI stuff that I've implemented in the game as sort of a library for myself started off in the map editor because it's something I needed in the map editor just functionally for it to be usable. And also the map editor itself, I think, is just really interesting. And it's built into the game. And I think it's likely as well that the map editor will make it into the final released game. That it's going to be something that users can use. But I'm not promising that yet, but I think it's likely that we'll do that. Whether that's something where we have an online component where you can download other people's maps, or whether it just has to be you share them through your website or whatever, that's something that remains to be seen. And then physics is another interesting one. Boy, there's a lot of stuff to do, isn't there? Physics is another interesting one. Obviously, actually, did I say this? I don't know if I said this before, if I made it clear, but the engine, so the rendering in the engine, maybe it's best not even to mention it, but the rendering in the engine is raycasting, like in Wolfenstein 3D, right? But the raycasting also is useful for physical interactions in the game, like not just rendering. So I've put it here under physics, but I guess it will get discussed in both cases. Yeah, the way that we do raycasting, like axis aligned bounding box collisions. In fact, it's not only collisions. I just wrote a thing here saying collisions, but we use axis aligned bounding boxes for a bunch of different stuff, right? And then the physics of motion of objects in the game is also kind of interesting. My code for it is rather messy, but it's not that bad. I think it will be at least mostly comprehensible when I go over it in a video and explain it. It all happens like in one function, so that's good, and it's not object oriented, so that's another plus. And then we've got and audio. So that'll be a nice, like when I want to have a bit of a mental rest. Maybe I can do one of these videos. I think the audio stuff is very straightforward. Yeah, I think did I already make a series of? I think I already made a video about adding audio to the game before I did this intro. So so there's like me sort of like live coding the music implementation of the game already. Audio effects is an older one. That is pretty straightforward as well, but it's pretty cool. And we'll go over that. So yes, dear editor, this is something that I missed from the intro video, so we can cut this in somewhere. Hopefully it makes sense. Thank you.